Uh, Thank you very much for being with us today, and I think we are going to enjoy your talk. Okay.
Yeah,
All
thank you
right.
so much for inviting me here.
Yes.
All right, I'll start my screen share. Can
Yes.
you guys see my screen?
Yes. Perfect. Yeah, we see that. We
Okay,
see
all
that.
right, great.
Yes.
Okay, let's get started then. So welcome to Transforming Inspiration into Innovation, a journey into AI and ML research. So today, I'll be covering some of my personal journeys into my path into AI, and also maybe how you can pursue a potential path in research or AI or app development. My name is Tianyi Huang, and I'm the founder and president of the Apping Club, which is a global student nonprofit organization. And I'm also the student ambassador at the Apping Foundation. Formerly, I worked as an LM research engineer at Master of AI, which is a Forbes 30 under 30 startup. And recently, I've had paper accepted at several top-level conferences, and also been the organizer and speaker at universities and industry-level conferences. So to get started, I like to define what is research, right? So the general definition of research may be like this process of inquiry, right, was targeted at discovering, interpreting, and understanding a question. And this process may include the following steps, as you can see on the presentation. But I feel like this general definition is just not good enough, because why should we confine research into just a definition, right? And to visualize this, I've created an illustration. And this is an image from Google. I literally just searched up a nail on a board. But let's say you have a nail on a board, right? Then you might think about, like, if I ask you, how can I put the nail into the board? The first thing you might think about is a hammer, right? The standard way of solving it. So in research, there are many types of research. And what I've seen in high school research is that a lot of people, they focus on application-driven research. And so you might be wondering, what is application-driven research? Their research that their purpose is more about applying a theory that might have already existed into a use case. So in this example, you might be wondering, what is application-driven research? It will just be changing from the tool of using a hammer to maybe a screw, right? Screw already exists before. And then both hammer and screw a screwdriver can also be used to drill the screw into the board. And then there's another type of research. That's what I call academic research. It's about finding something that doesn't exist before. Obviously, there are many, like as I said, they're all research. But academic research to be classified something that's different from application-based research. And in this case, this is going to look really funny. It's an AI-generated image. I would define academic research as finding a new method that's not a screwdriver, not a hammer, not an existing tool that can be used to do the same task. It's something new, something that doesn't exist before, right? I'll say that's research. And then next is also, why do people do research, right? I think of research as this process of breaking through beyond the initial conception of the ideas, right? As you saw in the previous example, it's about finding that new method that doesn't exist. And usually people are driven by three factors. One is passion. This is something that I value the most, and also the reason I have been able to achieve what I have currently achieved in research. And second, curiosity. Research starts with the research question, the RQ, right? And in order to form the question, you want to be curious in the field. And curiosity comes from this innate human nature, right? One of the greatest benefits or pros or cons, doesn't really matter how you think of it, is human curiosity. We like to explore the unknown. We like to ask a lot of questions, and we want to keep that, right? We want to figure out what we are like, oh, so why do this happen? Or how do this happen? And let's figure out why, right? I want to understand why does it do this? And lastly, if you have curiosity and passion, you need drive, right? Once you have drive, then you can really persevere through this process of research. Research sometimes can be very grueling, right? It can be very challenging. So you need to have the drive to persevere. But out of all of these three factors, they're all very important. But passion, this love for research is something that's very important. And you can't really force it. I cannot just tell someone to be like, hey, you need to have a passion. You need to be passionate. It doesn't work like that, right? Like, for example, for me, I've tried a lot of different stuff. When I first started research, I wanted to explore what am I truly interested in, right, in research. So I did a lot of like kind of like random hobby projects. I tried AI plus music actually. One of my first research project was on figuring out how can we address the pre-existing limitations in music generation by developing a new architecture called multi-dimensional recurrent neural network to address the pre-existing limitation in terms of redundancy in the LSTM model. And I also try to explore AI plus environment, AI plus like robotics and etc. And then finally I found what I love, AI and NLP. I really enjoy working in that direction, right? And you will know when you find the passion because even though I don't really recommend it, but you will definitely feel the interest, feel the energy, and also you will be working on it and have many sleepless nights. I'm not saying like, oh, you should not sleep, but you will know when you're passionate about something, right? And also, so when I first started research, in fact, before I started research, there was something that I founded and also like caused me to go into research, aka creating apps. And then the thing I founded was the Apping Club. An Apping Club, the whole point was a way to basically create a dissemination of knowledge and information to students, right? And our mission is to contribute to equal and open access to leading information in AI and app development. We want to share this impact-driven learning to empower students to tackle these real-world challenges. And at that time, I created a bunch of apps. That was kind of like the start of my journey, right? And it all started with MIT App Inventor. And at first, it was about app as a field of impact. As I mentioned, I wanted to explore a bunch of different fields. I wanted to create a bunch of hobby projects. And one of the examples of the apps I created was App Plus Sustainability, SnapCook. And essentially, it's a very simple app, right? All it does is just you take a picture of food, and it will call a computer vision model, a classification agent to determine, oh, what the ingredients are, right? So in this case, it will identify, okay, it's 2 tomato and 3 eggs. And then we can feed those information into an agent, right? Like ChatGPT. And then that can process the information, generate the recipe, and then provide the information, as you can see over here. And the whole point and the inspiration that came from this project was that, hey, my mom cooks a lot of food. And then sometimes she doesn't really know what to cook. And and then she want to try something different. And it takes a lot of time to search, right? And so what if we can just simplify this process by using one click, right? You take a picture, generate, right? It's very fast. That was the whole inspiration behind the project. And obviously you can reframe it and then basically kind of like gift wrap it to talk about, oh, how it addresses this global challenge of food waste, right? So this is app plus field of impact. It was kind of like the start of what I did. I did a lot of other apps similar to this template. I did, for example, another app I did was Edbox. That was app plus education. And what it does essentially, kind of like an online marketplace for used school supplies, but using an AI to do automated matching and smart matching. And then beyond that, where I really started to touch this field of research, Okay, hold up. Sorry. Wait. Oh, okay, wait. Do you guys still see my screen or no? Okay.
Yes,
Okay, all right.
yes, we see the screen.
Okay, yeah. And then after I was working on like the apps, what I started to work into is bridging fields, right? And then one of the first projects where I really started to touch research was Scribe AI. It started with the app, by the way. The app was essentially I wanted to explore hardwares, right? So I connected MIT Inventor with Arduino, and it's 3D printing, and I created this project with one of my mentees actually. And this project was on how can you automate handwriting processes with AI and also robotics. And the idea that was behind this was honestly very, you might say, unconventional. Because at the time, I had a class called AP European History, and there was just a lot of notes. So I was just like, hold up, what if you just build a machine that writes for you? And then what if you just train an AI model that can write in your own handwriting? Oh, homework machine. Yeah, that's exactly the idea. But essentially, that was when I first really touched into like, oh, you can actually bridge these different fields. And then I realized, wait a second, no one have ever really worked on a cost-effective study for building a very cheap handwriting system. Because pre-existing system, like if you search up CNC machines or pen powders online, they'll cost around $150 to $200. Whereas my system over here is under $50. So that's why afterwards, after I finished the project, um, I wrote a paper on it and I published it with Richard, right? And that was kind of like the start of my research journey. And then so afterwards, I was very intrigued by this field of AI. Me personally, I was intrigued because I was like, hmm, for me, I have always wanted to make an impact on this world, right? That was like a dream of mine. And then when I saw AI, I was like, this is the next big thing. This is something that's going to change the world. And I'm very fortunate to be born in this era. I'm not born too early, where we're still in the stages of neural networks. And we're in this period where there's this bloom of AI. And it's not like we're in this late stage where I can't really make a contribution to this field, right? It's something that I can actually feasibly contribute to. For example, in this paper, right, the whole point was identifying how we can optimize pre-existing system by making it cheaper, so it's more cost effective. And then in AI, I saw so much more potential optimization or solutions or questions I wanted to ask, I wanted to find out the answers to. So what did I do, right? And what you can do is self-learning. This is one of the most important processes, I think, in research, in learning, because it develops independence. This word is very important, independence. The ability to solve, to question, to complete a process or a project entirely on your own. Why is this important? Because when you're coding, when you're doing the research project, you will reach a bunch of random errors and very weird problems. For example, in one of my research projects, I was running one of the results, and then the result just did not generate. It literally, the error message is deprecated, Python deprecated. I was like, what? Deprecated? What does that mean? It means like the thing just broke. And then, so funny enough, I just closed the tab, like the VS Code, and I copy and paste all the code locally onto another repository. Reran the same code, zero change, same code. It worked. So therefore, sometimes there's like very weird issues like that. That's what I hate about Python sometimes. But it will not happen in TypeScript. But in general, there's some very weird issues. And You will never learn how to solve a lot of those bugs if you just taught or guided through the entire process. I personally mentor students, for example, it was in Apping Club and etc. And I know that in my process of mentorship, what I value that's like very important is letting the students do it themselves, right? It's this process of self-learning. And then I recommend a few resources to check out. The first step in self-learning, or even getting started to research, is to read papers. You will not understand most of the papers at first, but through this process of trying to understand the paper, you will learn a lot. This is incredibly important. So, for example, right, archive is very useful and good because there's a lot of free papers out there. You can, and for all fields, it's not like just AI. As you can see, there's astrophysics, energy, nuclear, like mathematics, a lot of stuff, right? Or even biology. If you go into AAAE, the papers will actually cost you money. If you have an institutional account from a college, it will usually be free. But archive have all of these for open source because they're all preprints. So let's just say I'm interested in like large language models, right? And you can search, and you'll be able to find out some of the newest paper that was published on this field. And then you can obviously do advanced search. And then this right now it's like based on the newest papers. And if you look at this, then this was published on March 13th, 2025. March 13th, 2025, right? This is our recency. So this means that you will be able to see, and it's still March 13th. Essentially, there were so many papers published at that time, right? So this just goes to show, oh yeah, $43 result, I can see. There's a lot of paper that's out there that you can read. And as you're reading these papers, you'll be able to understand a lot of new information and just trying to understand it and annotate it, right? And if you see over here, you can press view PDF, by the way, and you'll be able to like actually read the paper. Loading right now. But yeah, it's all available because it's a preprint. So what this means is that it's usually not published. I mean, it's published as a preprint, but not as like a archival proceeding or like our archived paper, right? But that's something that I think is very important in doing to get started. And if you're determining like, oh, what should I read at first if I'm doing AI, then I would recommend two papers, which is one, attention is all you need. This one is essentially the holy grail of transformer models. And also the transformer model, if you don't know, is kind of like the start of the current revolution in AI, right? It was the basis of the BERT model and the current ChatGPT, right? This is such an iconic figure in the future, if you do AI research, or if you have been doing AI research. I just sent a link to this paper in the chat. And another paper I heavily recommend checking out is called Knowledge Distillation. This paper is by Jeffrey Hinton, and it's one of the holy grails for machine learning. So I heavily recommend checking that out as well. Okay, moving on. Another resource is MIT OpenCourseWare, and not just MIT OpenCourseWare, any open or like online university OpenCourseWare, because they usually provide a lot of classes and information for free. And what's very good about it is that you can learn about all the concepts that you will not be to learn just reading papers or YouTube videos. YouTube videos are good, but they mainly just provide a surface level understanding. They're like an overview, right? It allows you should watch YouTube videos on the field to get an understanding of what it's about. But it's not something that you want to do if you're trying to really get into it to do research. Research, you need to have very strong foundational understanding of the mathematical behind it, right? And you might be like saying like, oh, I'm reading this paper. What is this? I don't understand any of these mathematical algorithms. That's where this comes in, right? So if you go to MIT OpenCourseWare and then search up computer science, I mean mathematics or computer science, you'll be able to find out the course catalog for basically a lot of the math and the proofs that will allow you to understand essentially most of these. And also another thing is like even if you don't understand these, through reading a bunch of papers, you'll be understand like the general scheme of these mathematical algorithms. For example, this one, if you remove the t, this is just a standard softmax function. To define softmax is essentially just finding a probability out of vectors, right? And once you understand that, then you'll be like, oh, by adding this t, I'm able to control the smoothness of the output. So it makes sense. So like just reading a bunch of papers allows you to already gain a general understanding of the math. And then through learning about these open coursework it's completely free and all the lectures is on there, you'll be able to actually gain a stronger foundational understanding of these concepts. And then for actually creating projects, documentation is king, right? So every single thing that you use have a documentation, whether it's Python, like a coding language, or like an API. APIs, they will have very good documentation usually. For example, if you want to use, oh, how do I use LMs? You'll probably be using OpenAI, because it's very easy to navigate, right? Well, there's a documentation exactly on how you can, get started with it, how to use it, what models they have, context, concepts, all of these where you can use and read to figure out how I can use OpenAI in my code. If you don't want to use AI, OpenAI, you can just search up, Llama documentation. Right, and then you'll be able to see all the documentation on how to use Llama, how to install Llama into your computer. If you don't know, Llama is like the other very big LM model. That's like kind of like ChatGPT, but it's developed by Meta, and it's also open sourced. So highly recommend checking that out. And what open source means that you can essentially locally download it onto your computer and will be free to run. So they will only locally use your computer. All right. Anyways, and beyond that, another thing is like coding the project, right? Obviously, you can code projects on VS Code, but sometimes you want to do prototyping, which is very important in research. I want to just try something out to see if it works. I want to visualize something. I want to visualize the data set. Sometimes think that you don't have to create a whole repository for it, right? And what you can use is Google Colab, right? Google Colab is like a notebook. It's like you probably heard of you may have heard about Jupyter Notebook. This is basically the same. If you don't know it, by the way, you can transfer Google Colab and download it as like a Jupyter Notebook file, and then it's completely transferable. And then there's also a getting started guide on how to use it and stuff. So you can also check that out. There's like a documentation for literally any tool you want to use. And same thing for Streamlit actually. And then essentially, if you're coding Python, you will know that Python is not a language you can use to create websites or demos, right? You will usually have to use languages like React. If you don't know what React is is essentially a computer science program where you can use to create websites or apps. React Native for mobile apps. This is essentially the industry level version of MIT App Inventor. And a Streamlit essentially allows you to create very fast app and demos using a very simple language, what they call Streamlit. You essentially use a simple HTML, CSS, plus Python to create your apps. So it's very good to create like a very simple demo for your app. In fact, if you go onto my GitHub, a lot of my stuff, like a lot of the demos I have created, is also in like Streamlit. So for example, this one, right? You'll notice like, oh, okay. It's like the running the Streamlit app. I can actually show you a demo of what it looks like right now. Let me pull it up. I have to open the code. But these are all open source, so you can also find it just by like, going onto my GitHub. But let me pull it up real quick. By the way, I noticed like someone was raising their hand while I was talking. I can answer your question right now if you want. All right. So if you run the code, right? So as you will notice, most of my code here is written in Python, but so running the Streamlit app, I'll be to have this like demo on my local host. And then so for this project, it was about like predicting harmful algorithm like risk levels. So if I enter these values, like when change to 9, let's predict high risk. It'll basically call the AI model, which is saved over here, .pkl file, and then generate a prediction because the model is trained on predicting the chlorophyll A concentration level. And then these like as the UI, it's all created using the Streamlit. And then all of these are in the app.py. So this is like the Streamlit code for the app that you're seeing right now. And as you can see, it's actually not that complicated compared to if you were to completely code this with a React package. So that's why I feel like it's a very useful thing that you can potentially check out. All right. By the way, at the end of the presentation, I'll be sharing the slide link. You will have access to all of the links provided on the slide, so you can check it out yourself in the future. Okay. And then this is kind of like this is like I've never given a presentation like this, so it might be kind of weird. So as I was saying, this is kind of like my process in research, and also I'm trying to talk about like what you can do in research. So the next step is how to publish, right? So usually while I was doing my research journey, I first created a bunch of apps, right? And I started creating apps that was more related to research. And afterwards, I wanted to like, because I wanted to get more into research, I did a bunch of self-learning. I basically spent 1 year to just learn. I just read a bunch of papers. When I say a bunch of paper, I meant like every day I wake up, I go into archive, and then I will search for some papers and then scan through the abstract because as you saw, right, it's very new papers. So it will usually update every single day with new papers. So what you can do is you can scan the abstract and then if it's interesting, then you can read the full paper, you can scan through the full paper. And I did that process repeatedly for a whole year. And that allowed me to gain a humongous amount of foundation knowledge and also having like an idea on what the field is doing. Because archive is the most recent papers, as you saw. So it's the most accurate in reflecting what the academia world or the research world is doing. Any YouTube video that you see that talks about AI news this week, those are usually outdated by a few days because they need to spend time in editing that video and creating a video. So they're usually outdated by 1 week. You might be like, oh, outdated by 1 week is not that big of a deal. It is a pretty big of a deal when you realize that AI is a field that moves so fast. 3 months ago, right? Today is March. Right now we're March. 3 months ago, in the research world, everyone was super hyped about something called multi-agent system. You may have heard someone called Andrew Ng. He's a very influential individual in the field of AI research. This is the person, by the way. But his focus on the multi-agent system right now, like after 3 months, is not that popular anymore because we realized that, hold up, multi-agent system is not, it's very powerful, but it's currently already being integrated into basically all LLMs, so it's not that helpful anymore. So yeah, so that's just to give you a perspective and an example of how fast the AI industry is moving right now. Anyway, so now on to how to publish, right? So there's a difference between conferences and journals. These are kind of like the two ways of publication, right? You can publish. So by the way, another thing is like the difference between a preprint and actual paper, right? A preprint, as you saw, it's still a form of publication, but it's usually like a way to showcase preliminary work, aka work that are very new, and they're not really complete. They're still changing, right? Maybe they're still doing like running more results and something, right? And then publications that are archival can be in proceedings, in journals, or not in proceedings. And when they're not in proceedings, they're usually still classified as a preprint, or they can be a finalized work. But most of the work will be in proceedings. And journals, they don't have something called in proceedings. So it's just in the journal because you have to go through the entire peer review process. But as you can see, conferences are significantly faster. It's a very obvious to know why, because journals usually take around 1 year for just the review process. Some journals might be faster, some journals might even take longer than a year. But conferences, it depends on what track you're doing, right? If you're doing the main track, then 6 months or 4 months even to get your paper out. And that's the entire review process to a presentation date. And yes, the conference, well, as the name says, a conference, you will attend the conference, right? Journals, they don't usually have the conference. It's just you publish in a book in the journal. So the whole point is that it has shorter review cycles, right? And as I mentioned how fast the research world moves, the point of the conference is for timely dissemination of these new papers, new information, right? Journals take like a whole year. So the information might be outdated. This is actually very specific for AI. That's also the reason why I added a section saying, why are there so many conferences in AI? Because for any other field right now, compared to AI, it's very different. For example, if you're doing biology or if you're doing biomedical, right, then your go-to like basic publication is Nature, right? The Nature magazine or the Science magazine. Those two are one of some of the most impactful and the hardest journal you can get. Well, for AI, we have a bunch of conferences. That's one of the reason why it's very different because the field moves so much fast. So because it's like the hype right now, right? So it moves so fast. So what scientists realize that it's not very useful for us to publish in a journal when it takes that long. That's why we need to have conferences. So in AI, there are 3 conferences that are like the top level conferences. They're on another league compared to any other conferences, which are NeurIPS, ICM, and ICR. And to put in perspective how competitive these conferences are, there's something called the H index, which is essentially the average citation amount you get for each paper, right? And what you'll notice, so what you'll notice is this. Oh yeah, so this is like the Google Scholar metric for top publications, which is basically some of the most accurate way of you can evaluate the impactfulness of the publication, right? So as you know, Nature, you can submit a paper all year long for the peer review process. Something that you can do all year long, right? And then you will notice that NeurIPS ranked number 7, right? This is very insane because NeurIPS only happens once per year. So you can only submit paper at that one particular time that is probably like 1 month. As you know, 2 months from they open the submission till they close the submission. And then they're able to reach a H5 index that's very high, right? So this is very insane because these are journals. And as you know, journals you can submit at all times. And obviously if you go to like, this is if you don't do computer science, obviously you can just like, let's just say you want to do chemical science. Then you'll be able to see these are the top journals for chemistry, right? And if you want to do computer science, obviously, then you would select computer science, which I'm currently blind right now. Hold on. Okay, found it. So this is the ranking for computer science. I mean AI actually, sorry. AI specifically. So NeurIPS is number 1, ICR is number 2, ICML is number 3, and there's a bunch of other conferences, right? And some of these are journals. But for AI, you will notice that, there's the top. The top are not journals, they're conferences. And the whole reason for this is because of the nature of AI research, of it being so fast and how fast the field is in generally moving. For different fields, this will be different. And I'm not saying like, conference is just the way to go, right? If you're doing another field, let's just say you're doing like cancer research, then your go-to is definitely not a conference. It's gonna be it's probably gonna be Nature. So yeah. All right. So you might be wondering, you have mentioned about these conferences, these journals. How do I actually submit to them? So my suggestion to this question is honestly just if you have completed the steps I have mentioned before, mainly this one, this is fine. You can do it. That's like good. But if you're doing like research, I'd say you have to finish the foundation, right? Once you finish the foundation, you found a topic that you're interested in, you wrote a paper on it, you did the research for it, right? If you want to publish it, then you have to submit it, right? And then the submission process is usually very complicated, to be honest. So for each conference, there's a call for paper. So we can go to NeurIPS right now. But to be honest, I do not recommend submitting to these kind of conferences as a high schooler, because it's almost impossible to get in. Because most of the people submitting to these conferences are going to be PhD or postdoctoral students, and you're competing with professors. To keep in mind, some colleges, they have kind of like a soft requirement for graduating PhD and AKA publications at these top level conferences. So you're literally competing with some of the best PhD students in the entire world, and they'll have a team. Then they have lab funding. You do not have lab. If you can get lab funding, that's great. But if usually you will not be able to get that much funding, right? I'm talking about like a lot of money, right? So I do not really recommend submitting to like these level conferences. What I do recommend, however, is you can check it out to understand the research process. As you can see, there's like a very long guide on how you can do it, and it's like the code of conduct and etc. But what you should do is to check out ASCO conferences. These are significantly easier to get in and a much faster way to share your research. So what you can do is that actually have a whole lot of conferences, right? If you go onto the ASCO website and you go to conference search, you'll be able to see like basically all the conferences, and you will notice that there's a lot of conferences, right? And there's essentially a conference for any field that you're doing. If you're doing neuroscience, well, you can just search up IEEE neuroscience conferences, and you'll find out conferences on neuroscience. If you're doing not that, AI, then you can search up IEEE AI conferences, and then you'll find out conferences related to AI. That's like by IEEE. And usually there's always going to be some call for paper that you can just read, like their guide on like how they view full call for paper, right? And then you can read their like introduction and what they are expecting and their submission instructions. But generally, this is going to be much simpler to get in and have it's like actually like practical compared to submitting to something like NeurIPS. So this is what I recommend in getting started. I'm not saying you cannot do NeurIPS. It's just in order to get started, you should start with something that's practical at first, right? There's like a progression. So IEEE is something that you can check out at first. And another thing to show you how many conferences there are, by the way, is this. This is essentially this is one of the submission platform that IEEE uses called EDAS. And this is not just for IEEE, there's a lot of other conferences out here. But you will notice that this is essentially a conference for almost every single month. So that's another benefit about submitting to IEEE conferences. If you get rejected, you can basically resubmit, right? So you can basically resubmit until you get in. Like you can basically resubmit unlimited amount of times. And you guys, again, these are all 2025 conferences. So there's a lot of conferences, right? So it's not that big of a deal if you don't get in. And what's beneficial about it is that you will get reviews from the reviewers. So you can use the reviews to figure out like, oh, what kind of level is my paper at right now? The reviewers review sometimes might be not as nice, but it will allow you to at least gauge like what kind of level my paper's at right now. So you can be able to use that to further refine your next draft. So IEEE is what I recommend in getting started. And if you're like done with IEEE, let's just say you got in like a bunch of paper into IEEE, and you can easily get into IEEEs, what I recommend as the next step is to, well, you can go on your conference list, and you'll notice that, oh, there's a lot of conferences below it, right? So you can submit to maybe something like a second tier conference, like AAAI, right? Or something like that. That's like not the top three, but over here, right? And then you can see how that goes. If you can get in, and then once you're like okay with that, then you can try for some of the top three. Because if you try for the top three at first, you will not feel happy because you'll just get rejected, and it's not very fun when you just get rejected, right? By the way, you'll also be asking like, oh, why is there H4E here? So there are like because of how big H4E is, it's like it's the largest like double E organization there is. There's like a huge variation of conferences, like a huge variation of conferences. Some of the conferences are very low level. For example, this one. This is a regional conference. And what this means is that it's a very small conferences dedicated for that specific region. Obviously, you can submit if you're not in the London region, but it's much easier to get in. And then there are the very hard to get in H4E conferences. For example, IROS. This is literally the world's best robotic conference. Like for example, number one in the field level, right? So it's very hard to get in. Or CVPR. CVPR is also one of the best conferences in the world. This conference not easy to get in. It is incredibly hard to get in. This is the same level as New York. It's not like it's like the same level as New York. And this is a collaboration between it's also, as you can see, it's also like with H4E. And also the CVP Foundation. I mean the CVF Foundation, which is the Computer Vision Foundation. So like there are very, very good H4E conferences that are incredibly hard to get in. But there are also like the easier ones. So what I recommend is climbing the ladder kind of. And also, if you're wondering how to submit a preprint, anyone can create an archive account. So you can create it right now if you want. And then you can start a submission. This is a general process, right? You do have to, since you guys are minors, you do have to like get your parents to obviously like, to complete the consent form and stuff. But in general, okay, right. And then you can choose a license. Um, Generally, you usually cannot submit a paper on archive unless you have an institutional account or if you're like endorsed by someone. So in order to get endorsed, you can reach out to people who have the ability to endorse you. Oh, and then you can tell them like about you, right? And then usually you can just submit the files here, and then you can complete the other process. But that's like the general process for submitting an archive. And then regarding how like you will see like latex a lot, right? Latex is also very easy. It's essentially just a way for you to write papers. For example, this is the example of a paper that I was working on recently, and this is the latex for it. It might look very complicated at first until you realize this is honestly just a template. And the actual paper is just like the following, right? Those are the paper. It's not that hard. It's literally just like the text and then some of like the special formatting options, which is very easy to understand. And then regarding like the actual bibliography, this is something I wanted to mention really quickly. Um, all you have to do is you cite the bibliography to the file name, which mine is ms.bib, right? So all I have to do is like /bibliography ms, and above it the style format I'm using. For this one, submit to ACM, still use the ACM format. And then for the bib itself, in order to get like the actual thing that you're citing, it's also very simple. So you search up the paper. Okay, got the paper, right? And you just press cite. Okay. And you press cite. And you can be like export citation to bib text. And what you can do is drag the file in, and then you have the bib citation for it. And you can just copy this, delete this file, and then paste it in your ms.bib, and it'll work. But obviously, I don't need the abstract. I do not need the keywords. So I'll delete those, right? And then you can also change this thing over here to whatever you want to call it. So when you're actually citing it, for example, like over here, you'll notice like there's the /cite, right? I'm gonna go to one example, like this. This will cite the actual paper, right? And if I Control F over here, This you'll find out that was the name for this one. So yeah, it's honestly the citation part. Some people think some people say it's like, oh, it's actually very complicated. It looks very complicated, but it's not complicated. It's generally pretty simple once you know the process. All right. And that's essentially how you publish a paper in conferences or journals. If you have further questions, you can feel free to reach out to me. But I do recommend starting with like the archive and the IEEE. And if you want to try to pursue a top-level conference publication, what I recommend, as I said, is to just to climb up the ladder and then hope for the best. It's honestly kind of luck-based. It's really hard, right? There's so many submissions every year. Like for example, for this one, the ICML submission this year had over 16,000 submissions. And every single submission, this is not the amount of people that submitted. This is the amount of papers that were submitted to this conference, right? And what this means is that let's just say each paper have 3 authors, then that's like around 50,000 people, right? So it's a very huge amount of people you're competing with. Anyways, the next thing I would like to share is Freeman's Guide on how to write a paper. This is one of the best guides, in my opinion, in terms of how to write a paper. So I heavily recommend checking it out in depth in the future. But right now, we'll go through it real quick. This paper is written by Professor Freeman, and he's actually a professor at MIT, and he's also with Google Research. And this is actually the official guide for CVPR tutorial on how to write papers and reviews. First of all, a paper's impact on a career. You should never work on quantity versus over quality. Quality is always key because a paper that is bad, okay, or pretty good will almost have zero impact on your career. As I've mentioned before, the IEEE conferences, there are so many of them, right? It does not impact your career that much. But getting into one NeurIPS will impact your career a lot, right? One NeurIPS versus a bunch of IEEE, people will choose the NeurIPS. So therefore, your paper needs to be creative, original, and good. So that's very hard to achieve, and it takes a lot of time. So that's why like the impact on the career, you should focus on quality over quantity, right? Okay, next thing. Just to clarify, there's a misconception of the research community, which is, this is our perception of the research community, right? It's like this it's very hard, right? It's very complicated. It's like they have a lot of scholars and they have a lot of time working on their paper. This is not true. This is the reality. Like a large crowded marketplace. There's a bunch of people there, like very random people too sometimes. And this is the reality of research. Research is not like anything that's like holy. It's normal. There's a lot of people doing it, and it's very crowded, right? And then this is how you should structure the paper, or how you structure a paper, right? You start with the question that you want to talk about. Then you think about, oh, what are some potential solutions to this problem, and what are solutions that doesn't really work? AKA trying to explain and answer your own research question. And then if the solution that you think about is like, oh, this is a very good idea, then you try to see, okay, does the solution actually work? AKA you run the results, right? And then you explain your results, AKA explain the solution, and then you compare with other people's solution and be like, oh, why is my paper better, right? Why is my solution new? Why is it unique? That's why you compare with others. This is usually reflected in something called the related works. At the end, yeah, see related works and how it applies to a different problem. And then this is an example of a paper structure. The introduction, related works, image, usually like the methodology figure, algorithm, experiment, then discussion. And then I'm not gonna go through the entire presentation because it's already 9:51, so I don't have that much time. But in general, you can go through this in the future. I'm gonna hop onto one of the section that's more fun to read. Yes, you should definitely treat the reader as how you would with a guest in your house. Oh yeah. Obviously, another thing that's very important in paper writing is the readership of your paper, right? AKA, how much people read your paper will directly correlate with how many citations you're gonna get. And citation is also key in research, right? You want to get more citations. Usually as a high schooler, that is definitely not a concern. But once you reach like, if you want to get recognition for your work, you want more citations, right? That's also the reason why people submit to the publish in journals and top level conferences, because once you publish in those kind of conferences, it basically tells the reader that like, oh, this paper is legit, it's trustworthy, because it already went through the peer review process. So it means the paper is high quality. If it's high quality, I can cite it. That's essentially kind of the purpose of why people want to submit to these top level conferences, and also obviously for the collaboration opportunities, right? But anyways, the title, as you can see over here, the title's impact on the readership of paper is out of the chart. It impacts your paper way too much. The reason for this is because, as you can see, when we go onto archive, right? I search up a random paper, let's see LM, right? The only thing I see is the title. So, so the title is very important. The second most important thing is the abstract. Why? Because when you click on it, the second thing you see is the abstract. And then lastly, the third thing you see is figures. Why? Because no one wants to read this. No one is reading this. You should read it, but most people they do not want to read this. This is very, it's like, okay, it's just there, right? So they look at this. And then they look at this and determine, huh, do I understand this? Is this interesting to me? So that's why they look at the figures. And as you can see, the read every word, aka reading the rest of the paper, has almost no influence on the readership of the paper. So that's why it is very important to make sure you have a very good title. And then regarding how to make a good title, it has to be interesting, right? That's why my title for this paper is called Super Buying Encoder, because it's different. You want to make your title interesting, so when the people see it, they're like, "Oh, that's interesting. I want to click on it." It's kind of basically like a YouTube video. You see the title, you kind of want to clickbait them. It's like, "Oh, this is an interesting title. I want to read it." Also, uh, yes, be honest. And then one of the last important thing I would like to mention is reviews, right? When you submit a paper, it goes through the peer review process. And you do not want to get easily rejected. So these are some quick and easy reasons to reject the paper. So right now, please place yourself in the perspective of a reviewer, right? You're a reviewer trying to reject a paper. You make a hypothesis, you say what you're gonna do, you don't do it. That's one of the biggest reasons, right? If you do not have state-of-the-art comparison or important references that are popular, then that's also a very big mistake. Are the results too incremental? Sometimes these two are basically the same. When we look at the results, like for example, let's go to the result. What we will see is that, okay, this is your proposed method. If your proposed method is better than every single other method on every single benchmark, it is very suspicious. It will make me think, how is that possible? So then I will go back and look at your methodology to see if it makes sense. If it's not believable, then I will think the paper is fake, right? And then the last two are stuff that you never want to make. You do not want to make sure, you want to make sure there's no grammatic error or anything, right? And then usually from the perspective, there's like some very easy rejects. and there's some paper that are very, very good. But most of the paper are gonna be in these two camps, right? Which is one, the cockroach. Two, the puppy with the six toes. To explain this, the cockroach is essentially the paper. The idea is like not that good, but they didn't do anything wrong. They have everything. You know, they don't have any obvious mistakes. So it's very hard to kill the cockroach, as you know. And in the same case, it's very hard to kill the paper. And then the second thing is the puppy with the six toes. There's something very wrong with the paper. It's very fun to read, right? It's very easy to notice that there's like six toes. Like, oh my God, that's not normal. But the paper is good. The idea is good. Everything's good, right? Like they have something that's very novel. And unfortunately, though, most of the delightful papers get rejected. As you can see, 2/3 of these get rejected, and 1/3 getting as posters. And then for the cockroach, 2/3 get accepted, and 1/3 get rejected. We do not want to write papers that are either of these. But unfortunately, your paper will most likely be falling into one of these categories. But obviously, you can try for this, but it's going to be very hard. So therefore, if you ask me, oh, which two of these is better? That is an impossible question to answer because on one side, if you want to get in, probably the cockroach is definitely the better option because two-thirds gets in. But that's saying like, oh, I'm recommending you to write a paper without an interesting idea. That's bad, right? You want to write a paper with a very good idea. So you should go for the delightful paper, even if it's a lower chance to get in, because it's a very interesting paper to read. So the reviewer will be very happy. And then because usually the delightful paper, right? They will most likely develop into a very good paper, as you can see over here. All right. So I will actually, by the way, if you just search up this on the Google, you will find it. So yeah, I do not have a particular link to this. It's just a PDF. So you can just like search this up. You will find it. It's like it's pretty popular. So yeah. All right. Um, with that said, that's essentially all about how to write a paper and also the general process. Regarding the future, I would say if you're trying to do AI research, the step to go is definitely first start with reading a bunch of papers, especially trying to annotate the papers and trying to truly understand what the paper is talking about. Second, determine, do I have an interest? Do I have a passion in this field? Right? Because you're not going to know if you have a passion if you don't try. So that's why I recommend you try a lot. But once you try and you realize you're not passionate, then stop. You should not force yourself to do something that you're not passionate about. If you're not interested in it, try something else. Right? You have time to try other stuff. So try until you find that thing that you're truly passionate about. And then once you find that thing that you're passionate about, then persevere. It's going to be very challenging. For example, every single time I submit a paper to a conference, what end up happening is that in the last week before the submission deadline, I will not sleep. Or at least sleep like for 3 hours per day. So essentially, that is not a good thing to, and it's not a very good thing. But it's very true for a lot of researchers, especially PhD researchers, and they will know the pain. So therefore, when you're doing research, you will also experience something similar. And in those times, you gotta persevere. Aside from that, research is not something that like you're ever like, just like forced to do, or it's not something that it's just a task. It should be treated as an exploration of a topic to discover something that you want to figure out, to discover a question that you always want to ask, but you didn't know the answer to, right? That's kind of how I treat research. AI is this black box, right? We don't really know how it works. We don't know why it produces the outputs that it does. But I want to figure out how we can optimize this black box to give a better response, right? That's kind of the question that you want to have when you're approaching a field. But with that said, that's basically all. And thank you for having me here to give this talk. Sorry it was a bit messy. There was just a bunch of information, I think, regarding like this research process. It's definitely not enough in like 1 hour to go over the entire process, but I hope it gave an overview of some of the information that will be potentially useful in your future paths.
Hey, Tony, thank you very much for your outstanding presentation. Yeah, you see, you are just starting in the research field, but you look like a professional. You mentioned all the interesting part and how motivation, you see, is key. It's very key in the way to publish and to research in a good way. So I really appreciate what you told us, and I will open the floor for questions. You had any questions? Anybody for Tony or some comment? Any? No question. Ana Lucia, I will ask you. You see, how you find this presentation? Give me your feedback.
Well, hello. I really like this presentation and especially about like research on AI. It's a really interesting topic and I did had a question and it was how do you start it on this field of research and AI? How did you discover this passion?
That's good. Hey,
Yeah.
Tony.
So honestly, when I was as you probably saw before AI research, I was into app development, and actually before that, I did something called web development. Basically during COVID, I was kind of forced to do coding, but during that time, I always had a prediction. I always thought like at that time there was something called GPT-2. Essentially like the thing that was not popular, no one was looking at it. It was the precursor of GPT, ChatGPT. It was made by the same company. As you know, OpenAI in a research lab, right? Before they have done a lot of research in this field, it's not just one day they pop off ChatGPT. By the time when the GPT-2 was there, it was very bad. It was giving you very weird responses. If you ask it 1 + 1, it will say, you should answer 1 + 1. It doesn't tell you 1 + 1 is 2. It just answers, you should answer 1 + 1. And I was thinking like, in order for AI to truly be the big thing, there has to be something that generalized, aka something that people that relies on, right? And I always thought like, in order for AI to be truly revolutionized, that technology is something that people have to rely on. And then once ChatGPT came out in 2021, I was like, oh my God, students are gonna use this to do their homework. That was the first thing that I thought about. And it did, right? So much students are using ChatGPT to help with their homework. And do you know what this means? This means that people are going to rely on the technology over time, because once students use it for their homework, it also transcends to the next generation, causing this to be a kind of like a loop. And then once I saw that, I was like, this is going to be the next big thing. And my prediction came true, and I was very like happy that it came true. Kind of, I mean, I don't want students to use it for their homework, but I'm just saying like it was like I was so happy that the prediction came true, and I was just like so incredibly, I guess, inspired by it. And afterwards, I want to figure out, okay, how can I contribute to this? This was my shot, right? It was like when I saw it, I was like, this is probably the only thing, the only field in research that I can actually contribute to. Any other field, I have always been interested in physics, but once because I was like, oh, I want to make a time machine. I know it's not happening, but I know that I am not gonna be able to contribute to that field that much, because there's researchers in physics or biology for the field of hundreds of years, and their research is so incredibly hard and takes forever to get into. I have huge respect for those researchers in those fields. But AI is something that was more practical to me that I could actually contribute to. So that's why I was so passionate.
Thank you much. Any
Thank
other
you.
questions? Rosario? Oh, thank you, Ana Lucia. Rosario, you want to ask a question?
I need to say thank you for all information because I need the research very actuality. Thank you. For me,
All
it's
right.
very important, and for my students and from all person, because we go to the research and maybe sometimes it's not very actuality. It's not very
Hmm.
actual. It's very long time ago.
I
Yes.
see.
Thank
Okay.
you.
Uh,
Yeah, thank you.
Tony, Rosario, she is one of our science teachers. Okay. Yeah.
Oh, okay, I see.
Here we had science and math teacher, and we had the K-12 student. Okay. So
Hmm.
that's it. Right. Okay. Any other question, guys? I'm
I
seeing
think like the Daniela is raising
Daniela. Yes, Daniela.
Yes, good morning, everybody. And Dr. Huang, thank you for your presentation, are very interesting. My question is for the next week. We need to present Dr. Ariata.
Yes.
The presentation uh, should be one for team, one project for team, or each member of the need to present what we develop.
Yeah, it has to be individual presentation. You see, the teachers will present what they had in mind for their project, and the student also, they had to do it. It's not just one for each group. It's one for each person of the group. Okay? Do you get
Yes,
that?
thank you.
Yes.
Yes, thank you.
All right. Yeah, I thought that some people, you see, came late. It probably is because of the change in timing. You see, because Eastern time move a little, but
Yes,
yeah,
I'm
yeah,
sorry. I think that it will be at 10 a.m.
yeah,
But
yeah, yeah,
I
yeah.
I
It
just
was,
forget the change in the hour.
yeah,
yeah,
it was, it was 9 Eastern time. You see, it changed a little bit, so it's like
yeah, the time.
or 9. It's 9 o'clock in Puerto Rico, so that is the same that in Boston, right? Yeah,
Uh-huh, yeah.
right. Yeah, but look what we have. I think Tony presents, you see the slide, and we have a, a video. Okay, we already make a video, so it will be available also. Everything that Tony says, it will be available in our webpage. I will send you a message to all of the attendees now. Okay, perfect. Yeah.
I
Any
don't
other? Yes, Ana
Hi,
Lucia. Yes.
I don't have a question, but I just wanted to say like thank you so much for the presentation. It was super detailed and especially like all the information that you provided, all the links and also like how to, write the article. It was really informative, so thank you so much. And you've achieved so much. So like I just want to congratulate you. You're so cool and thank you.
Yeah. Thank you
Yeah,
much.
thank you.
Yeah. I think it was a really great presentation. You see, I'm an old guy, and to see you all of you just going into the field at early age, that's was my hope. But I didn't do that because in my time, you see, it was difficult to get what you are having now. Okay, so my first presentation, you see, my first research was actually when I did my PhD, late, very late, you see. It was in my 30s, so it was really late. So that's what I'm pushing, you see, to train students at K-12 now. It will be my passion to do that for the rest of my life. Okay, that's it.
Yeah,
Yeah,
that's really
thank you very
inspiring.
much. Yes,
Uh-huh.
yes, Tony.
No, I was saying like, yeah, I really respect your work and also feel like what you're doing is a very amazing thing. I just wanted to say like, I feel like, yeah, with like how the era changes and how like technology changes and how like basically everything on the internet now compared to before where information was so hard to be found. It's definitely like
Yes.
we're in this different age now. So it's very cool to see that like students are able to approach research much younger. It's like very interesting. It's like a different world now. So yeah.
Yes, absolutely. I think, and we are pushing that around the world. So we are doing that. Okay. Okay, guys, thank you very much and see you next Saturday. Okay. And we will send you the information. And for you, Tony, I really appreciate you coming to this group. All right. Your
Yeah,
first
thank
session.
you so much for inviting me here. All right.
Yeah.
Have a good
Thank you.
weekend.
Thank you.
Bye-bye.
Thank you, Tony.
Bye-bye.
Bye-bye.
Thank you so
Bye-bye.
much.
Bye-bye.
Thank
Yeah.
you.
Okay. Take care. Yeah.